This is the Simplifying Square Roots video, part 2. Okay, the steps are the same. Okay, you type the problem into the calculator. If you get a whole number, then you're finished. The whole number is your answer. You're done. Don't do anything. If you get a decimal, then follow the steps below. Make a factor tree. Circle pairs or buddies. The pairs or buddies come outside. Underline the leftovers, and those stay inside. The difference in today and the previous video is that we are going to have a number that's already on the outside of the square root. I like to circle this number right away. This 5 has already been buddied up in a factor tree. It already found its buddy. It's already been brought outside the square root, and so I like to circle it so that I know when I circle my other buddies that they go with the 5 on the outside. Okay? And then I'm going to start factor treeing. Okay? You can break 40 down multiple ways, but if you can't think of anything that divides into 40, you can always try 2. If 2 doesn't work, try 3, then try 5, then try 7. Okay? So I'm going to do 2. You could have done 4 and 10 or 8 and 5. It doesn't matter. Okay? So I'm going to do 2 and 20. I also like to scratch out my numbers once I've broken it down, so I'm not tempted to circle or underline it. Okay, 2 is prime, but 20 breaks down. 20 breaks down into 2 and 10, or 4 and 5 would be fine. 2 is prime, so I don't have to break that down, but 10 breaks down into 2 and 5. Okay, so circle your buddies. 2's are a buddy. This 2 doesn't get buddied up. We cannot circle all 3 of them. If you circle groups of 3, then you're doing a cubed root. We're doing square roots. We can only circle pairs. And the 5 doesn't have a buddy. Again, this is why I circled this 5 to begin with. So you're not tempted to put those 5s together as a pair. They're not a pair. This 5 here already is paired up. This 5 is already on the outside, so I'm going to leave it on the outside. I'm going to bring my 2's to the outside. Then on the inside is going to be left 2 and 5. So on the outside I'll have 5 times 2 is 10. On the inside of the square root, 2 times 5 is 10. Okay, if I put 10 square root 10 in the calculator and 5 square root 40 in the calculator, I should get the same decimal, which means that my factor tree is probably right. Alright, again, I have a number already on the outside of the square root, so I'm going to circle the 7 so that I remember that it's out there and I don't forget about it. And then factor tree 27. 27 is divisible by 3 and 9. Again, I'm going to scratch out the 27 so I don't try to circle it or underline it. 3 is prime, but 9 breaks down into 3 and 3. Again, I'm going to scratch out the 9 so that I'm not tempted to circle it or underline it. Circle your buddies, so these can be buddied up, and this 3 is not buddied up. So on the outside of my square root, I have a 7 that was already out there, and then I have this pair of 3's that I just circled. So 7 times 3 is on the outside, and this 3 here that didn't get buddied up is on the inside. So 7 times 3 is 21. Square root 3. The most common mistake on these problems is forgetting your outside number. Most people will say the answer is 3 square root 3, and that's not true. You have to remember to leave the 7 out there and put it in your final answer. Alright, last example. Again, I'm going to circle the 12 right off the bat so I don't forget about it. And then I'm going to start factor treeing 48. You don't have to start with 2. You can start with 4. You can start with 6, whatever, but I'm going to start with 2. 48 divided by 2 is 24. Get rid of the 48. 2 is prime, 24 is not, so 24 divides by 2 and 12. Get rid of the 24. 12 divides by 2 and 6. And 6 divides by 2 and 3. Okay, so start circling your pairs. So these 2's can be paired up. These 2's can be paired up. And the 3 has nobody. He doesn't get paired up. So on the outside, I have a 12 that was already there. Okay, I can't forget about that guy. Then I have a pair of 2's a pair of 2s, and the 3 is stuck on the inside. He didn't have a buddy, so he can't come out and play. So on the outside I have 12 times 2 times 2, which is 48, and on the inside I have a 3, and that would be your final answer.